Let's calculate some cross products geometrically. And a great place to start are with these basic unit vectors I, j, and k. Recall I hat is 1, 0, 0, j hat is 0, 1, 0. And I would like to calculate the cross product of 3i cross 2j. And we're going to do this purely geometrically. So you should think about 3i as kind of coming out of the screen parallel to the x-axis, and it's going to be 3 units long. 2j is going to run kind of across the whiteboard, parallel to the whiteboard, and it's going to be 2 units long. And to give us some perspective there of length, I'll just mark some tick marks there. So 1, 2, 3i and 2j. If I want to find their cross product, the first thing I might think about is the area formed by those two vectors. They're at a right angle to one another, which makes this really easy to calculate. There's 6 square units of area there, 3 times 2. The next thing I need to do is determine the direction of the cross product. Take your fingers of your right hand, point them parallel to the direction that 3i is going in because that vector is first. Curl through that 90-degree angle to 2j, and your thumb is going to go up from our perspective along the positive z-axis. In other words, my unit normal vector is going to be k hat. And my cross product is going to point upwards with a length of 6 units. So the cross product is going to be 6 times k hat. Let's do another one. Let's take 2j cross I. So 2j is plotted here still, and I hat is coming out this way, just 1 unit now. So I think about the little rectangle that they form, and if it's that little shaded area there, that has an area of 2 units. But because I'm now going in the opposite direction, I'm taking j first, then I second. Take the fingers of your right hand along j, curl them towards I, and your thumb's going to go down. So my normal vector n hat is going to be minus k hat, and then the length of the cross product is 2, so our result is minus 2k. It's very easy in this way to calculate cross products of these basic vectors, I cross j. If I start with I and I cross to j, it will get me the vector k hat pointing upwards in our picture. But if I go in the opposite direction, j cross I get minus k. Let's do another one. If I do j cross k, so I'm going to just draw a little picture. Here's j, here's k. Take the fingers of your right hand, start with j, curl through that right 90-degree angle. The thumb is going to come out at the screen pointing at you, and that's in the direction of I. So j cross k is I. Everything has length 1 here, so the cross product's going to have length 1. There, if I go do k cross I now, so I start here with k. I curl the right hand fingers to I. My thumb's going to point in the direction of j, and so k cross I is j hat. And there's a nice way to kind of keep this all organized. I'm going to draw I, j, and k like in a little circle here, and I'm going in alphabetical order: I, j, and k. When I get to k, I just cycle back to I. And if I want to find the cross product of any 2 of these, I just follow the arrow. So if I want I, j, I will get k. And because I went in the direction of the arrows, it's going to be plus k. But if I went j cross I would get minus k because I'm flowing against the arrows. If I want k cross I, I'm flowing with the arrows, so that gets me positive j. But if I wanted I cross k, I would get minus j. The cross product of any one of these with itself would be the 0 vector, and that's because the angle between the vector and itself is the 0 vector, or is the 0 angle, and the sign of 0 is always going to be 0. So the cross product of a vector with itself is always 0. In this case, I cross I is 0, or j cross j is 0, etc. You can treat cross products algebraically as long as you are sensitive to the order that you perform the cross product into. Remember this non-commutativity. If you change the order of the product, you change the sign of the result. But other than that, as long as you're sensitive to that, you can use all sorts of properties of algebra to calculate cross products. And I'm going to illustrate that here with an example. We're going to take 2i minus 3j plus k, and we're going to cross that vector with I plus j minus k. And I am simply just going to treat this like an algebraic expression by distributing across all these cross products, always being careful to think about the order that I'm doing it in. So to get started on that, if I want to do this calculation, what I'm going to first do is do 2i, and I'm going to distribute that through each one of the terms in the second factor here. Just remembering that this 2i, is on the right hand or on the left hand side of the product. So the first thing I'm going to do is 2i cross I. That's going to be I cross I, which is 0. So it doesn't matter the 2 or anything like that. Because I'm hitting I with itself, I will get 0 for that term, and I'm not even going to write anything. The next one's going to be 2i cross j. So what will I get here? I will get I cross j, that will get me k, and then everything scaled by a factor of 2 here. I'm going to get 2k for that. I'm now going to take the 2i and multiply it by the minus k here. So look at my diagram here. I cross k gets me minus j. But I also have a coefficient of 2 and negative 1 here, so it's going to be minus 2, and the resulting vector is minus j. So we'll actually have plus j when we simplify. I now move to this minus 3j term, and I'm going to distribute that across each one as well. Minus 3 times minus 3j cross I is going to get me minus k, because I'm kind of going against alphabetical order, and I just keep my coefficient of minus 3. Next one is going to be 3i. If I do, notice here I skip the j cross j, that's 0. Don't care about that one, so it's going to be j cross k, and j cross k gets me I, and then minus 3 plus 1 gets me plus 3. And you continue on in this fashion. K cross I gets you j. So k cross I gets me j. Next one, k cross j gets me minus I, because I'm going against the grain here. And then the k cross k gets me 0. So I have a bunch of i's, j's, and k's floating around, and I'm just going to rewrite this in like terms, combining like terms and writing things in order. I have 2i coming from 3i minus 1i. That gets me 2i. And then the next term will be 3j. That comes from plus 2j plus 1 here, so 3j. And then the last term will be 5k by adding all the k's that show up. And now we've computed this cross product purely algebraically, just knowing how to do it with the basic unit vectors.